mathematicians. In this video, we're going to practice using function notation to find input and output values. Now we have three different functions, each defined using a different representation. Function f is defined using a table of values. X is the input and f of x is the output. Function g is defined using an equation where x is the input, f of x is the output. And finally, function h is defined using a graph. X is the input, h of x is the output. All right, let's now do a whole bunch of different examples. Let's start off with figuring out what f of -2 is. For f of -2 with a let's see, function f, that's defined using the table. When we input -2, we output 7. So it's there ready for us. So f of -2 is equal to 7. What about function g? What is g of 4? What happens when we input 4 into function g? Well, for function g, whatever comes in, we have to multiply it by 1/2 and then add 6. So that's going to be 2 plus 6 and 8. So g of 4 is equal to 8. What about if we use the graph? What is h of 6? On a graph, we input 6, that's our input. So let's come find our x value of 6 and come up to where it hits the graph. And that point, the output is 9. So on the graph, when we input 6, the output is 9. So these are all examples where we know the input and we want to find the output. What if we go the other direction? What if I give you the output and we have to figure out the input? So for example, what is the input to the function f that outputs 9? So f is defined again with the table. We look at the table. Here is the output of 9. We get that when the input is 2. So f of 2 is equal to 9. Let's do g. What x value do we need to input to get an output of -2? So this is really, we can set up a nice little equation to solve. Our output is -2, and that needs to equal 1/2 of an x plus 6. So what I've done here is I've replaced g of x, which means output, with our output -2. Let's go ahead and solve this equation. I'm going to subtract 6 from both sides. -8 is equal to 1/2 of an x. To undo that multiplication, I'm going to divide by 1/2, which is the same as multiplying by 2 on both sides. So -16 is equal to x. This tells us when we input -16 to this function, that's when we'll get an output of -2. And finally, let's think about our graph. I'm going to put that over here. What would h of x is equal to 7? What input gives us the output of 7? So let's come up on our output to 5, 6, 7. Come over, here's the graph, and let's come down and see the input is going to be 2. So we know h of 2 is equal to 7. So using these definitions, we can go both ways. If we know the input, we can find the output, or if we're given the output, we can determine the input, going both directions. Finally, let's do a few more, let's use them in a few little calculations. Here I'm going to say, for example, 6 times f of 0. Okay, so I'm going to come look at my function definition for f. When I input 0, I output 1. So this is the same as 6 times 1, which equals 6. Or let's say we have g of 2 plus h of 14. All right, we're going to take these one at a time. If I input 2 into my function g, 1/2 times 2 is 1, plus 6 is 7. So that evaluates to 7. And for h of 14, when I input 14, this function outputs 3. So notice with the order of operations, we evaluate the functions first, and then we'll add their results together, their outputs together, and that's equal to 10. One last example, what if I do h of 2 times 5 plus 1? For this one, for the order of operations, we're going to do this arithmetic first and then input the result into the function. So this is equal to h of 11. And if I input 11 into my graph, my output is 5, 6, 7 is equal to 7. So h of 11 is equal to 7. I hope some of you have noticed something or maybe been curious about something back here. I didn't give you the full story here, did I? Let's go back and look at this graph. We said, what is the input that gives us the output of 7? So we went up and we said, oh, when the output is 7, the input is 2. But that's not the full story. The output is 7 is also true when the input is 11. Maybe you realize when we got that over here as well. So this is really subtle. Sometimes a particular output will have multiple inputs. So in this case, the output is 7 when the input is 2, or the output is 7 when the input is 11. And you might say, well, wait a minute, doesn't this mean it's not a function? So with a function, every input has exactly one output, but it's absolutely fine for multiple inputs to have the same output. So that was a little nuance. Maybe when I did this example, you picked it up then, maybe here, but that is an important thing to look out for. Sometimes multiple inputs can have the same output. Something to think about. All right, so this little video, I hope, showed you that we can use different function definitions and that using function notation, we can figure out, given the input, what's the output? Given the output, what's the input? And we can also use function notation in expressions. All right, I hope you found this video helpful. Your next task is going to be doing some practice on a handout.